Okay, so here's for part D and E. So I've written down the T equals PD P inverse, but what's not really given is you need to put this N into the power on matrix D. This is where, like if part D said find the number of customers after like 12 years, you would just plug in 12 into this matrix. And so it'd be really easy on the calculator. You could just type in, matrix A times, like plug this as matrix B on your calculator and raise it to the 12th power, and then do matrix, do A inverse. Okay, and plug that one in, and then times it by whatever this initial value given is. In this case, it's 1200, and then it will just spit out the matrix of how many customers are in X and how many customers are in Y. And so that's easy if you know the power. But in this problem, it doesn't give us the power. It just says after n years. So this number here has to be in n. And so we apply it to the 1 and the 0.7, which is why I have the n here. Notice there's no n here because 1 to the n is just 1, no matter what n is. 1 to the 99th power is still 1. So that n doesn't need to be there. So the next step we have to do is multiply all of these together. And really, the order does matter. We have to multiply by 1200. But we have to leave n in this and actually get an expression for X and for Y, because this is going to equal some expression for X and some for company Y. And it actually tells us we just need the one for company X. And so the way to do this is kind of, the order matters for matrices. So like you have to multiply P by D to the N, or you can multiply D to the N by P inverse, but you can't like mix these around in the orders. One thing you can do, and this is the reason why I wanted you to write the 1/3 out here, is the first thing we want to do is apply that to this initial matrix. That's going to make our life a lot easier. So the first operation we're going to do, let me erase this, is just whatever number that fraction was that came out of your inverse, you just want to multiply it by whatever the initial matrix, the initial state matrix is. So we multiply those by 1/3 and we get 400 apiece. Okay, so now we can like get rid of, we've taken care of this and we've taken care of this, sort of. Okay. Now we can follow. It's like we're replacing this matrix right here. So we're going to do P inverse times this initial state matrix once we've scaled it down. And we're going to do P times D to the N. And then we're going to times those two together. So let's do P times D to the N right here. See what that looks like. So we have to multiply this row times this column. And the way matrices work, you do 1 times 1 plus 1 times 0. So that's just 1. Then to get this entry here, we have to do this row again, but now times this column. So 1 times 0 plus 1 times 0.7 to the n. So it's just 0.7 to the n goes there. Okay, the next row in our answer, we have to move on to this row. So this row times this column, 2 times 1 plus -1 times 0 is just 2. And then we do 2 times 0 plus -1 times 0.7 to the n, which is -0.7 to the n. So that would be the result of P times D to the n. Would look just like that. Okay, now we can do what's left of P inverse after we've gotten rid of the 1/3 and times it by the 400 and the 400. So I'm going to replace that here. Move our 400 down here. And now we do this matrix times that one. You could do this on the calculator as long as you just re-enter these numbers. Like if you don't feel comfortable doing row times column by hand. So I'm going to do it by hand. 1 times 400 plus 1 times 400. This answer should be just a 2 by 1 matrix because this is 2 by 2 and this is 2 by 1. So the answer is going to be coming from these outside numbers, 2 by 1. So 1 times 400 plus 1 times 400 is 800. And then we move on this row times the same column. 2 times 400 plus negative 1 times 400 is 400. Because 2 times 400 is 800 minus 400. Okay, now we're going to, last step is multiply these together, and then we get the expression. We're going to get an expression for x and for y. And so again, it's nice to keep in mind what our answer should be. This is a 2 by 2 matrix times a 2 by 1, means we should get a 2 by 1. We're just looking for an answer here and here. So we do 1 times 800 plus 0.7 to the n times 400. And now this we can't really simplify this because of that power of n. We just need to write everything down. 1 times 800 plus 0.7 to the n times 400. So I'm going to write the 400 in the front times 0.7 to the n, like that. That's the expression for x. That's actually the answer to part D. We don't need an expression for y, but maybe a question asks you for that. So we would do 2 times 800, which is 1600, and then plus negative 0.7 to the n times 400. So minus 400 times 0.7 to the n. That's the expression for y. Okay, so that's part D. That's why it's 5 points, because that is a lot of work, a lot of multiplying. So then, hence, write down the number of customers in the company that we expect to have in the long term. Actually, you could have gotten this answer. It's only 1 point. We could have gotten this before if we just did P D to the 1000th power times P inverse times the initial state. It would tell us X and Y. It would tell us the long term. But now that we have this expression, this 800 plus 400 times 0.7 to the n, it's even a little bit easier, because if they want the long term, you could just plug in a huge number here, or you could realize that if you let n become really big numbers like infinity, this part of the equation just goes to 0, which means we're doing 0 times 400, so that goes to 0, and we just get 800. We would expect company X to have 800 customers in the long term. I mean, maybe you could have even guessed that. Maybe not. So that's why that's only worth 1 point. Okay, so I hope that helps. Thanks for watching.